Okay, I'm Michelle Robinson, representing Minera Camargo. I'm presenting Los Picachos de Sinaloa. And first of all, I'd like to thank you all for coming. And second of all, I'm going to tell you why this is one of the biggest and most important copper and gold projects in this part of Mexico. Okay? Okay. Forward. Okay, we are located in southern Sinaloa State, Mexico, about 75 kilometers due east of our current position here. We're on the edge of two map sheets, the Cacalatan map sheet to the west and the La Rastra map sheet to the east. We're in the western foothills of the Sierra Madre Occidental, and elevations on the property range from 300 to 1,300 meters. Next. Back up one. Okay. The project consists of 4 mining concessions overlapping a combined surface area of 4,000 hectares. There's about 50 gold-rich polymetallic veins known from historically exploited mines. There's a geological potential for a significant porphyry copper deposit related to Paleocene granitoids. A recent LIDAR survey accurately locates about 670 excavations related to historic gold mining and the roads, trails, and access routes. The database includes about 750 meters of RC drilling, 5,050 meters of diamond drilling, and about 1,200 meters of underground mine chip channel samples and surface trench results. The historic work summary: this is a relatively new project. In 1983, the Consejo de Recursos Minerales staked about 32,000 hectares overlapping the Viva Zapata Mineral Reserve. In 1997, Thunderbird Projects purchased the San Agustin mine, reporting values of about 81.2 grams per ton gold and 73.36 grams per ton silver across 1.2 meters. In 1999, the Servicio Geológico completed geological mapping and stream sediment geochemical sampling of those 2 map sheets. And in 2003, Minera Tango acquired the first exploration concession in the district with an average result of 11 grab samples returning values of 6.3 grams per ton gold and 75.2 grams per silver, as well as about 1% copper. Next. Okay, this is a map of the data from the Consejo de Recursos Minerales. What I've outlined in the polygons are the stream sediment samples, and anything with a value of higher than 120 ppb gold is in red, and the range from 60 to 120 ppb gold is in orange. The Picachos concessions are outlined in navy blue in the middle of the project. And to the southeast of us are the 2 of the properties of GR Silver outlined in green. And to the northwest, some of the properties of Vizsla are outlined in royal blue. The actual values, I've made a chart to the left where I've noted the maximum value in each camp. So you can see from the chart that the maximum gold value in the Plomosas camp is 700 ppb gold. The maximum value at Panico is 400 ppb, and the maximum value at Picachos is 2,600 ppbs. You can see for silver that the relationship is in reverse. Picachos does not have a strong silver footprint, but Panico and Plomosas do. For copper, Picachos wins the competition with 300 ppm copper. For Plomosas, well, you can guess by the name that they win that one, and the highest zinc and molybdenum values are in Picachos. Next slide. Okay, to try to understand the differences between Picachos and the camps closest to us, we need to take a quick look at the geology. This is a map that was published by Dr. Ferrari and his colleagues in 2018. It's of the Western Sierra Madre. The Picachos project is labeled Tango here because the underlying concessions are the Tango concessions. And what I need to do is cover the ground up to Piedras Verdes. And a major conclusion of this talk is that the geology underlying Tango is a lot more like Piedras Verdes than it is the camps either to the south or to the north of us. So just briefly, we'll go through the geology, starting from the oldest rocks first. Pre-laramide basement, anything that's older than early Cretaceous is in purple. That's actually pretty complicated. It includes schist, meta-andesite, meta-sediments, and limestone. Those are overlain by Cretaceous to Paleocene volcanic rocks in green, pale green. And Montoya described those for us in her paper in 2019 for the Teotita camp. Those are intruded by the red rocks. Those are the Cretaceous Eocene intrusive rocks. Those contain the porphyry copper deposits. And I've picked the closest operating one, Piedras Verdes, at 500,000 tons of 0.3% copper. The rocks are unconformably overlain by two colors of ignimbrite, the Eocene and Oligocene ignimbrites in pale peach, and the early Miocene ignimbrite in darker peach. These ignimbrites are punctuated by Oligocene domes, both felsic and mafic, and I think that's probably important for Vizsla's project, that these could be the rocks generating the magmatic hydrothermal fluids at their camp. Next slide. Okay, we're just going to do a quick pit stop at Piedras Verdes, take a look at what the map looks like over there. We see on the left-hand side, the metamorphic basement is in blue. On the right, it's in purple. It's because the maps were done at two different times. The intrusions, which are here labeled late Cretaceous to early Paleocene, are in red. The footprint of mining is outlined in green. And that coincides very well with a sericite alteration anomaly marked by the Consejo. The older rocks are unconformably overlain by ignimbrites in the peach color. Next. Okay, this is what our property looked like in 2000. Well, there are no metamorphic rocks here at all. The green is Paleocene andesite. This is overlain by what looks like flat-lying ignimbrites in both the pale and the darker pink colors. And there's an intrusion there that's an Oligocene granodiorite. We can see that the alteration, both sericitic and propylitic, overlaps both the Paleocene and the Oligocene ignimbrite, and that the mines are mostly in the andesite, but some of them are in the ignimbrites. Next. Next slide. Okay, this is what we think the geologic map looks like. We think there's metamorphic basement here, and it's argillite. It's in the blue-green in the hanging wall to the San Agustin vein in the lower left corner of the map. As we traverse to the northeast, we cross over into green rocks. These are meta-andesites intercalated with sammites. They're metamorphic. Note also that they're pretty much upright. They dip about 80 degrees to the south. Continuing our traverse to the northeast, These rocks are unconformably overlain by ignimbrites that dip quite steeply to the northeast. And in the southeast portion of the map, the rocks in yellow, those are bimodal, rhyolites, and mafic rocks, and they dip steeply to moderately to the southeast. In the northwest corner, there's a plutonic complex that includes Monza granite, and granodiorite. Next slide. Next slide. Okay. So going through this a bit more slowly, this is the hanging wall to the San Agustin vein there in the core. It's argillite, it's medium gray, lamentated rocks, locally with pyrite laminations and graphite. We don't know the age. We suspect it might be as old as Paleozoic. Next slide. Next slide. Okay. This is the meta-andesite and the intercalated samite. There's the field stop FJ201 in the upper right of the map. And there's the drill core showing the andesitic hanging wall in the lower left part of the map. The andesite, it's medium gray, magnetic. We don't know the age. It could be as old as Jurassic or as young as Cretaceous. Sodium, much higher than potassium. Intercalated with samite and pretty much upright. Next slide. We're looking here at the southernmost field stop into the Gabbro unit. And what we see here is a coarsely crystalline plagioclase hornblende. And to the south of the notebook, there's a xenolith of andesite included in the Gabbro. Next slide. Next slide. Okay, that's what compositionally it looks like. It plots between quartz Monza Gabbro and Gabbro. And we don't know the age. All we know about the Gabbros in this part of the world is that they're thought to be early Cretaceous, mainly based on a cross-cutting relationship where an early Cretaceous granodiorite was dated with uranium, lead, zircon, and they got an age of 136 million years. Next. Next slide. Okay, moving up into the ignimbrites. This is field stop FJ0437 on the contact between the metamorphic andesitic basement and moving up through the first layer of ignimbrites. There by the rock pick, we see a clast of coarsely crystalline gabbro, and we also see a clast of the andesite. Next slide. This is where we took the geochron sample. It was taken between the Cobre veins. We can see that the rock is medium gray. It entrains clasts of the basement andesite. When you look at it under the microscope, you can see the pumiceous clasts, quartz hornblende. This has an age of 74 million years, a Campanian age. So based on this data, these rocks correlate to the Zokavon volcanics, which are the same rocks that Montoya dated in Teotita. Okay, next slide. Monzo granite. It's more mafic. This is the first of our plutonic units. It's more mafic than the granodiorite with about 57% silica. It's mainly orthoclase, some feldspar. We don't have an age date for this. Next slide. Next slide. Okay, this is the granodiorite. It's a pretty typical I-type granodiorite. Contains xenoliths of the basement through which it erupted. We have an age date of 66.3 million years from zircon contained within these rocks. Next slide. Next slide. I don't know. Okay, this is at the northern part of the property. There's a prospect of molybdenite. It looks like it's in C-type sericitic veins. I just confirmed the sericite short time ago with a new TerraSpec. This is sample 20817, and we have a rhenium osmium age date of 66.3 million years plus or minus 0.33. So it's the same age as the granodiorite. Now, why does this matter? I'm getting there if this matters. Next slide. Okay, this matters because the porphyry deposit, copper deposits in western Mexico are in an age range between 50 and 75 million years of age. Furthermore, the porphyry copper deposits with more than 8 million tons of copper formed between 69 million years and 54 million years. So the Picachos prospect is located in the productive window for porphyry copper deposits. Next slide. Next, okay. Okay, so where are the porphyry coppers? You can see them starting at the border between Mexico and the US. That's Cananea. To the south is La Caridad. Moving further south, we get into Suaquí Verde, Piedras Verdes, Santo Tomas, Tomiapa, and at the bottom, this is Astango. This is a map that I like even better. To the right, this is the 1 to 250,000 SGM copper data for stream sediments. Anything with a high potential for a copper deposit is marked in red. And you can see that those copper anomalies align very well with the porphyry copper deposits. Next slide. I've taken the 1 to 50,000 SGM data. You know, I already did this for the gold, so all I had to do was change the thematic mapping and light up the copper. So the Tango property, the Picachos project, is well located in a very strong copper anomaly. Anything higher than 120 ppm up to 300 ppm is marked in dark green, and the range of 60 to 120 ppm is marked in the pale green. Next slide. Next slide. Okay. So what does this look like in detail? I've come back to Piedras Verdes. I'm showing you the outline of mining in the red outline. And I'm showing you the stream sediment geochemistry with the same scale, where 60 to 120 ppm copper is in pale green, and 120, in this case up to 360 ppm copper, is in dark green. Okay, next slide. Okay, I just have one more field stop. We're going to take a look at the breccia here at trench number 117047. Next slide. There's the breccia in that location. It's a beautiful black matrix breccia. It has fragments of aplitic or alkali feldspar ferric granite and a matrix of quartz, tourmaline, and disseminated sulfides. It looks really similar to the black matrix breccia that sits on top of Buena Vista del Cobre. Next slide. So, what does the breccia mean? I asked Doug Kerwin, and he sent me some slides. This one at the right belongs to him. And it just means vapor pressure exceeds lithostatic pressure. The rock fails catastrophically. And we get those beautiful angular fragments frozen into that liquid, vapor, whatever, with quartz, tourmaline, and sulfides. The values from the trench, we didn't expect a lot in it. We didn't see a lot in these types of breccias at Cananea, but we do get between 200 and 900 ppm molybdenite. You can see the sulfur peak in the middle in yellow, and in green, it ranges between 50 and 100 ppm copper. Next slide. Next slide. Okay, now I've done the geology to the northwest of the Cocomeca Fault. That was the big fault that bisected the property into two triangular pieces. So we've looked at that. It had abyssal metamorphic rocks that were standing pretty much upright. It was overlain by Campanian ignimbrites that were also pretty steeply dipping, and then punched through by these Paleocene granitoids. Now, just to complete the map, I just have to pop over onto the southeast side of the Cocomeca Fault and do a field stop there. And what we see here is this gentleman is standing underneath a bunch of really steeply dipping tuffs. So you remember when we started this, that geology, it was all flat. All those ignimbrites were all flat. I'm telling you, there aren't any flat rocks. Okay? So we did a geochron date about 100 meters above where this gentleman is standing at a site called UNAM 27410, and that result was 62 million years. So these rocks, these Paleocene rocks, are just a little bit older than the granodiorite, which has the porphyry copper type mineralization. Now, I just have to finish coloring this map in. That yellow part, we're just going to do one stop there real quick, because I talked about flow-banded rhyolites and how I thought they were important to Vizsla. Okay, move on. Next slide. Okay, there they are. Beautiful flow banding. But you can see that this mine working with, it doesn't have any silver in it, it's just gold. So I think in this case, the flow-banded rhyolites are related to the Paleocene volcanics, and that they really don't have silver like they do to the north or to the south of us, but that we're dealing with this copper-gold event. Next slide. Okay, this is, they aren't just rhyolites, there's some mafic rocks in there. These are in the La Gloria mine adit. They're amygdaloidal basaltic trachyandesites. They're gray-green, non-magnetic, potassium much higher than sodium, so they're schotonites. Next slide. And so this is it. Presto changeo. All I had to do to show you how this looks like Piedras Verdes, I took all our metamorphic rocks. That's the argillite, the basaltic andesite intercalated with samite, and the gabbro, and I colored it blue. So that's it. That's your metamorphic package, just like you see at Piedras Verdes. Your red rocks, all the intrusive rocks, the gray ones, the pink ones, I colored them all red. And the volcanic tuffs, the late Cretaceous Zokobon volcanics, I've colored in peach. And the Paleocene bimodal volcanics, I've colored in pale green. So now you can see the porphyry. I know you couldn't see it before, but there it is. It's in the red rocks. Next slide. Okay, I didn't talk about the alteration. I'm going to do that now. I think the only thing I want to show you on this slide is that to the southeast of the Cocomeca Fault, where the veining is, the alteration types are mainly propylitic or they're argillic. And to the northwest, the observed alteration types are mainly sericitic. Okay, I'm just about ready to wrap up here. So now this looks more rational, we can understand it better. We have the gold in the Paleocene volcanics, southeast of the Cocomeca Fault. Below that, we see the molybdenite in the northwest part of the concession, where we saw the breccias. And in the two diagrams to the right-hand side, you can see copper and silver more or less coincide with each other in the central part of the concession. And I think that's the last, one more slide, and I think that's it. Yes, that's my last slide. Thank you very much for coming. And if any of you want to see any samples, just come and see us at booth 301.